So we're going to give you strategies for factoring polynomials. The first thing is to always check for a greatest common factor. Now, sometimes you'll just see right off the bat, oh, there's no greatest common factor. But if there is one, you want to pull that out first. It's much easier to take care of that first than to try to do it later on. And then next, I kind of have these numbered weird, but you're going to check to see how many terms. How many terms are in your polynomial. If there's 2 terms, then it's probably either the difference of squares, the sum of cubes, or the difference of cubes. Okay, so it's one of those 3 things usually. If it's going to factor, it's going to be one of those 3 things. If there are 3 terms, then it's a trinomial. So you have your trinomial. You have your trial and error. And a lot of times when I was doing examples, I kind of did this thing where, you're multiplying to be a number, you're adding to be a number. So there's trial and error, there's the AC method. And it might be a perfect square trinomial. Perfect square trinomial. Now, sometimes when the numbers are small, even if it's a perfect square trinomial, you can just do it with trial and error or the AC method. If the numbers are large, like it looks like it's going to be one you don't want to do that with, you might see if it's a perfect square trinomial. Okay. And then if there are 4 terms, it's most likely a grouping thing. And then last, I'm going to add a 5th here. You can always check by multiplying it out. Check with multiplication. Oh, and I forgot one other thing. You have to check and see if can you do more factoring. Can you do more? So once you get something factored, you have to check and see if there's more that you could do. Sorry about that. I'm trying to squeeze that in. But, like in this first problem, this next example we're going to do, there's a GCF. But see, once we get the GCF done, then we have to look and see, well, can I still factor? Okay, so this is really kind of a big deal. I kind of squeezed it in there. But you have to check and see, can I factor more than what I have done? Okay. Well, the best way to just learn is to just do lots of examples. So I look at this, and first thing I think, oh, GCF. Is there something they all have in common? And they all have a 2, and they all have an x. So I'm going to factor out the 2x. When I do that, I'm going to have x squared plus 4x plus 4. Okay, that is factored, but it is not factored completely. So we did the GCF. Well, that was cool. But now this is what I was talking about a minute ago. Can you do more? Can I factor this trinomial that's inside? Are there 2 numbers that multiply, oops, darn it, 2 numbers that multiply to be 4 and add to be 4? And the answer is yes, 2 and 2, right? Okay, in fact, this is a perfect square trinomial. So I'm going to have 2x, and then this trinomial is going to factor into x plus 2 times x plus 2. And you can check that by multiplying it out. So x times x is x squared, and I get a 2x and a 2x, that's 4x, and then 2 times 2 is 4. So I can check it with FOIL, and then if you distributed the 2x back in, that would get you the original. Okay, so this is an answer, totally acceptable. A lot of times I write it that way, but you could write it this way if you want. And that's fine too, okay? But that is now factored completely. So I can't break down the x plus 2 anymore. The GCF is out in front. We usually put it in front. And so that's what we're talking about with these strategies of how to factor something. So there's 2 more examples, I think, in this section. And they're a little tricky. They're a little odd, but you'll get to see a couple more.